The form below is called determinant 2 by 2, since it contains 2 lines and 2 columns. Here they are. The first line, the second line, the first column, the second column. The determinant is defined to be equal to the product of terms of the first diagonal minus the products of terms of the second diagonal. Example. Why did we mention the determinant in the cross product lesson? It's because when we have two vectors u and v given in an orthonormal system, their cross products will be defined by the following determinant 3 by 3. To find it, do the following. Take the first element of the first line, which is the vector I, and write it down. Then hide the corresponding line and column of I and take the remaining determinant to be multiplied by the vector I. Take the second element of the first line, which is the vector j, and write it down. Then hide the corresponding line and column of g, and take the remaining determinant to be multiplied by vector minus g. Take the third element of the first line, which is the vector k, and write it down. Then hide the corresponding line and column of k, and take the remaining determinant to be multiplied by the vector k. Then we add up all of the above answers, and we get the coordinates of the vector w. Example. Having the coordinates of u and v, u cross v will be given by this determinant. So as usual, take the vector I to be multiplied by the remaining determinants, then the vector minus j to be multiplied by the remaining determinants, and finally the vector k to be multiplied by the remaining determinants. Let's note that only the second term in the first line, which is j, should be multiplied by minus 1. Then, while computing the 2 by 2 determinants, you get the following answer.